Hello everyone, I am Professor Amit Solanki, working as an assistant professor in electrical engineering department of the S&D Engineering College and Research Center Yola, District Nashik. Today we will discuss the topic that is the rating of SCR. As you know that SCR, that means silicon controlled rectifier. So in previously class we have discussed about the various modes of operation of the SCR, like forward blocking mode, reverse blocking mode, forward conduction mode. Now in that topic, we will discuss about the ratings. Ratings means what about their voltage rating, current rating, power rating, or any other temperature rating. So we will see that one by one. So thyristor rating or SCR, silicon control rectifier ratings are very much required for the operating it in a safe zone. So that the reliable operation can be done when a thyristor does not violate its voltage and current rating during the working period. A thyristor or SCR may have several ratings such as voltage, current, power, dI by dt, dU by dt, turn on time, and turn off time. These are the various types of ratings which we have discussed one by one. So these are the common basic ratings which having the any system, any equipment, any component which is required for their operating in the safe zone. That means there are some conditions, there are some limitations of particular devices. So for that, we should have to read it. Generally, these ratings are specified in the data sheet given by the manufacturer. That means these ratings are always given by the manufacturer in the data sheet. That means, for suppose if you are purchasing one ceiling fan or one mixer, so in that box there are ratings are given. In that manual, there is also ratings are given for specific components for specific appliances. So these are the importance of ratings. Now, first we'll discuss the thyristor rating, which one that is the anode voltage rating. Anode voltage rating, that means this rating give us a brief idea about uh, without extending of the power of thyristor in forward blocking mode in the absence of the gate current. So this is the about the anode voltage rating. In this voltage rating, the peak working forward blocking or forward offset voltage in that it specify the maximum forward voltage, that means positive voltage that applied across anode and cathode that can be withstood by the SCR at the time of working. So these are the meaning of the anode voltage rating, or we can say that the V of dWm. In that figure, in that graph, you can see here that is the different types of ratings like V of dWm, V of DRM, V of DSM, and V of RRM, and V of RSM. These are the different types of anode voltage rating. Second one, that is the peak repetitive forward blocking voltage, and it is identified by the V of DRM. So in that rating, we can see that it specifies the peak forward transient voltage that SCR can block repeatedly or periodically in forward blocking mode. And in this rating is specified at a maximum allowable junction temperature with gate circuit open. During commutation process, due to high decreasing rate of reverse anode current, a voltage spike is produced, which is the cause of VDRM generation. So these are the all about the concept for the peak repetitive forward blocking voltage. Now third one, that is the peak non-repetitive or surge forward blocking voltage. It is denoted or identified by V of DSM. So it is the peak value of the forward transient voltage that does not appear periodically. And this type of over voltage generated at the time of switching operation of circuit breaker. And this voltage is about of 130% of the V of DRM, although it lies under the forward breakover voltage. As we already know that in case of SCR, there are forward breakover voltage. Okay, so as we have seen in the review, VI characteristic of SCR. So now next rating is the peak working reverse voltage. It is identified or denoted by V of RWM. So it is the maximum reverse voltage. That means we can say that the anode is negative with respect to cathode, which can be withstood by the thyristor repeatedly or periodically. It is nothing but peak negative value of the AC sinusoidal voltage. So these are the basic concept about the peak working reverse voltage. Next one is peak repetitive reverse voltage. It is identified and denoted by V of RRM. In that, it is the value of transient voltage that can be withstood by SCR in reverse bias at maximum allowable temperature. And this reason behind the appearance of this voltage is also same as V of DRM. So that is the function of the peak repetitive reverse voltage, that is the V of RRM. Now next one, that is the peak or surge or non-repetitive reverse voltage, which is denoted by V of RSM. It implies the reverse transient voltage that does not appear repeatedly, and so this voltage value is 130% of the VRRM. That means it lies under the reverse breakover voltage, that is the V of VR. That is, we are also discussed in the VI characteristic of SCR, that is the forward breakover voltage and reverse breakover voltage. Okay. Now next one is, that is the on-state voltage drop. That means what are the ratings for the on-state voltage drop? So this type of rating is, this is the voltage drop across the anode and cathode when rated current flows through the SCR at rated junction temperature, and generally this value is lies between the 1 to 1.5 volt. So these are the all about the concept for the on-state voltage drop. It is identified, that is the V of T. Now we are discussing about the forward dy by dt rating. That means forward voltage dy by dt rating. In that, the value of capacitance of the junction is constant. So therefore, when dy by dt increases to a suitable value, so that leakage current occurs and avalanche breakdown across junction J2. So this value of dy by dt is called forward dy rating, which can turn on the SCR without help of the gate current. In practice, it is not suitable to apply high dy by dt due to high temperature malfunction of the SCR. These are the all about the concept for the forward dy by dt rating. Now next one is, that is the voltage safety factor of the SCR. It is also denoted by the V of SF. So it is defined as the ratio of peak repetitive reverse voltage to the maximum value of input voltage. So voltage safety factor, it is denoted by the, or given by the some ratio factor, that is the peak repetitive voltage to the maximum value of input voltage. And voltage safety factor is usually taken from 2 to 3. Now next, that is the finger voltage of the SCR, and we can identify denoted by V by FV. So minimum value of voltage which must be applied between anode and cathode for turning on the device by gate triggering. Generally, this voltage value is little more than the normal on-state voltage drop. So this is the concept of the finger voltage of SCR. So before that, starting the current rating, as we earlier discussed about the voltage rating, that is the anode voltage rating. Now we will discuss about the current rating. As you know that in any device appliances, they have voltage rating different, current rating different. So in that case of thyristor, the current carrying capability of thyristor is determined by the temperature and its junction. So therefore, the thyristor is made up of semiconductor material. Its thermal capacity is therefore quite very small. So therefore, even for short over current, the junction temperature may exceed the rated value and the device may be damaged. So in this section, current rating of SCR are discussed for both repetitive and non-repetitive type of the current waveform. First will, that is the average on-state current. So I of TAV, as the forward voltage drop across conducting SCR is very low, the power loss is an SCR depends mainly on the forward average on-state current, that is I of TAV, and the average current rating of a phase control thyristor result in different conduction angles. If the same average current is permitted for different conduction angles, the current increases with the decrease in the conduction angle. So this is the concept of the on-state current. So this may result is an increase the voltage drop across the device, and the average power dissipation may increase, rising the junction temperature beyond the safe local limit. And therefore, the permissible average current should therefore decrease with the decrease in the conduction angle. And this current rating is of repetitive type and is of specified at the maximum junction temperature. Now you can say that this rating varies with the case temperature, and the manufacturer supplies the data sheets which shows the variation of the current rating with respect to the case temperature. So these are the some data sheets we are showing here. Try to show what are the ratings, identify what are the ratings are given by the different manufacturers. These are the I of T. These are the characteristics of the data sheet. These are the various parameters. Now RMS on current state. By the definition of RMS value, the RMS and average values are identical for direct current, and the RMS current rating can be of importance when applying thyristor to high peak current, low duty cycle waveform. In order to prevent excessive heating in the resistive element of thyristor, such type of metallic joints, lead and interference, the RMS value is given in the specification sheet of the SCR by all manufacturers. Now, the surge current rating that is given by the I of TSM. So when SCR is working within its repetitive voltage and current rating, its permissible junction temperature is never exceed. However, a thyristor may be subjected to abnormal operating conditions due to faults or short circuit. So this type of rating is maximum when repetitive surge current that the device can withstand. So therefore, this rating is specified dependent upon the number of surge cycles. At the time of manufacturing, at least 3 different surge current ratings for different durations are specified. Now, next one is the I2T rating of SCR. This rating is employed in the choice of the fuse. In choice of the fuse or other protective equipment for the thyristor. It is usually specified overload lasting for less than or equal to 1/2 cycle of 50 or 60 Hz supply. Now, next one is that is the DI by DT rating of the SCR, rate of change of current. While SCR is getting turned on, conduction stay in very small area near to the gate. So this small area of conduction is spread throughout the whole area of the junction. But if rate of rise of anode current, that means DI by DT is spreading velocity of the charge carriers is larger than the velocity of the carriers across the cathode junction. To overcome this problem, a maximum rate of rise of current is also specified during manufacturing of the devices. Now this is the holding current. As we also know that the latching current and holding current concept in the VI characteristic defined as the minimum. Holding current is defined as the minimum value of anode current below which the device stops conducting and turns to its off state. The value of this holding current is very small, usually in milliamperes, and the holding current occurs when the current in a device in on state is being decreased till it turns off. This current is associated with the turn off process. Now, latching current, it is denoted by IL, defined as the minimum on state current required to keep the thyristor or device in on state after the triggering pulse has been removed. So these are the gate characteristic of the SCR. We are already discussing the VI characteristic. That is also the gate characteristic. This is the gate non-triggering voltage. The equation is given by E of S equals to VG plus IG RS. So thank you so much for watching this video.